Hello everyone. Through this video, we are going to discuss question number 16 of exercise 3.2 in the chapter of matrices. So here goes exercise 3.2, question number 16. So the question is, if capital A is equal to 102, then after 0 to 1, then 2 0 3, this is the matrix given to us. Prove that a cube minus 6a square plus 7a plus 2i is equal to 0. In some of the questions, what happens, this I part is not mentioned. If this I is not given, in that case we have to put it from our side, then only it will represent a matrix expression. So in the solution part, first of all we have to evaluate what is a square, then only it will be possible for us to evaluate a cube. So given a is equal to this matrix, we are going to write here 1 0 2 0 2 1, then 2 0 3. So we shall be finding out what is a square. A square is a into a. Putting these values of a, 1 0 2, we have to write it twice, 0 2 1, then 2 0 3. Multiplying this with, once again, 1 0 2, then 0 2 1, then 2 0 3. Let's find out the product now. All of us know that we can find out matrix products using certain rules here. So what rule we have to follow? First of all, we have to check the order of the matrices. This is 3 by 3. Here also this is 3 by 3. So matrix multiplication is possible. Why so? Because the number of columns of the first matrix is equal to number of rows of the second matrix. So while multiplying, for getting a1 position, we have to find out product of the corresponding elements of this first row of the first matrix and the first column of the second matrix. So let us find out the product of the corresponding terms and put plus sign in between. So 1 1 1 plus 0 into 0, it is 0, plus 2 into 2, it will be 4. Then after, for getting a 1 2 position, this row should be multiplied with this column, means first row and second column. First row, this 1 2 means what? 1 stands for the first row of the first matrix and this 2 stands for the second column of the second matrix. So we can write here 1 into 0 will be 0, plus 0 into 2 will be 0, plus 2 into 0 will be 0 again. Then in the third case, for getting a1 3 position, we have to choose this first row and this third column. So what can we do? 1 into 2 will be 2, plus 0, second elements should be multiplied, 0 into 1 should be 0, then after 2 into 3 will be 6 here. Then after, for this position, this is what? A21 position. So of course A21 here, A21 means what? This is second row of first matrix and this is first column of the second matrix. So here we multiply, 0 into 1 will be 0, plus 2 into 0 will be 0, plus 1 into 2 will be 2 here. Then after, again, for getting a22 position, we have to choose this row and this column, then only both can be 2 2. So it will be 0 into 0 will be 0, plus 2 into 2 it is 4, plus 1 into 0 will be 0. Then for this third part, second row, third element, 8 to 3 position, the second row should be chosen and this third column is to be taken. So 0 into 2 will be 0. Then after 2 into 1 it is 2 plus 1 into 3 it is 3. Then after coming to the third row, this row we have to choose here and this column is to be taken for this position. So 2 into 1 it will be 2 plus 0 into 0 will be 0 plus 3 into 2 it will be 6. Then for this position it is A32. This is 3, this is 2. So 2 into 0 will be 0 plus 0 into 2 it will be again 0 plus 3 into 0 will once again be 0. Now let us check the third element of this third row. So 2 into 2 it is 4 plus 0 into 1 it is 0 plus 3 into 3 it is 9. So the result comes like this. It is 5, 0, 8, then after 2, 4, 5, then here I get 8, 0, then 13. So this is the result for this a square. Once we get the value of a square, we have to evaluate the value for a cube. So for a cube, what result we are going to use here? For a cube, let us check. A cube is nothing but a square into a. So in place of a square, I'm going to put this result 5, 0, 8, then 2, 4, 5, which is just evaluated, then 8, 0, then after 13. With this, I'm going to multiply the value of a. What is a here? 1, 0, 2, then after 0, 2, 1, then after 2, 0, 3. So these two should be multiplied. Now let us check the result. The technique already I have shown you. So 5 into 1, first result will be 5 plus 0 plus 16. In the second case, the first row and the second column should be multiplied. So 0 plus 0 plus 0 again. For this third position, again first row of the first matrix and the third column of the second matrix are to be taken. So 10 plus 0 plus 24. Then coming to this second row, we get here the second row into first column, means 2 plus 0 plus 10. Then after 0 plus 8 plus 0. Then after again 4 plus 4 plus 15. After that, while coming to the third row, we have to consider the third row here, third row of the first matrix and the first column of the second matrix. So we can write here 8 into 1 it is 8 plus 0 plus 26. Then after in this case it will be 0 plus 0 plus 0. Then for this position it will be 16 plus 0 plus 39. So after this we have to evaluate the values again. Simplified result we have to write here. So what can we write? The result comes as first value will be 21, second value will be 0, third value will be 34 while summing up. Then this result is 12, then after this is 8, then after this will be 4 plus 4, 8 plus 15, it will be 23. Then after 8 plus 26 it will be 34. then this is again 0, then after 6 plus 9 it is 5, then it is 55. So here is the result for a cube. Now let us move on to the expression. The expression is what? LHS is what? A cube minus 6a square plus 7a plus 2i. Now in the respective places I'm going to put the value. We had already derived the value of a cube in this way. This is the result for a cube. So here I am going to put the value here. 21, 0, 34, then 12, 8, 23, then 34, 0, 55. So this is the result for a cube. Then after it is 6 here, then value of a square already we got as 508, then after 2, 4, 5, then after 8, 0, 13. After that plus 7. Here in this case I am getting value of a as, actually here in place of a I shall be putting the value which is given to us for a, 102, then after 0, 2, 1, then after 2, 0, 3. After that plus 2, I is what? Of course order 3 identity matrix we have to consider here, then only further simplification will be possible. So order 3 identity matrix is this 0, 1, 0, 0, 1, sorry. So it is 0, 0, 1. So when we simplify this further, we shall be getting 21, 0, then 34, then 12, 8, 23, then 34, 0, 55 minus 6. Actually 6 will be the scalar term here. This will be getting multiplied with this entire matrix with all the elements. So this will be 30, then 0, then 48, then after it is 12, 6 2 ja 12, then after 24, then 30 again, then after 48, then 0, then 78. Then after what do I get here? 7, 0, 14, 0, 14, 7, then 14, 0, 21. And then after I get here 2, 0, 0, 0, 2, 0, 0, 0, 2. So this is the result I'm getting here. So after this I shall get, on simplification I shall be getting the result. If you observe, we shall get only the plus terms. If we choose, then 21 plus 7 plus 2, it will be 21 plus 7 plus 2 will be 30. Then after 0, these are all zeros. Let's place it properly. Okay, here we placed it. So when we add, it is 30, 21 plus 7 plus 2, the result will be 30. Then next term will be 0 if we consider only the positive matrices. 34 plus 14, actually this is 34, this is 14 plus 0. 34 plus 14, how much will it be? It is 48. Then after 12 plus 0 plus 0, it will be 12 only. Then 8 plus 14 plus 2 will be 24. It is 24. Then 23 plus 7, it is 30 plus 0. So the result will come as 30. Then 34 plus 14, the result will come as 48, then 0, all zeros are there. Then after 55 plus 21 plus 2, so the result comes as 78 here. Then there is only one negative matrix, that is this one. So we put the values 30, 0, 48, then 12, 24, 30, then after 48, 0, 78. So we observe that in both these two matrices the corresponding elements are same. So 30 minus 30, the result will be 0. Then after 0, then 48 minus 48 is again 0. Then 12 minus 12 is again 0, then 0, then 0. All zeros will come now. 48 minus 48 will be 0, then again 0, then 78 minus 78 is also 0. So this is actually the null matrix, and this is the required right hand side. So that is what to be proven. So ultimately we got the result to be LHS equals to RHS, hence proved. So this is the solution. So in my next video I'm going to solve the remaining questions of this exercise. Thank you.